Uh-oh. Sweet. Okay, it knows it's here. Good. Okay, good morning, everybody. So today's lecture is, so we're still basically covering the, we're still covering the basics of the Java language. And I'm still going to try to transition you from Python version of things to the Java version of things, right? In a few more lectures, we're going to move away from the here's Python, here's Java sort of thing, because in a few more lectures, we're actually going to start the object-oriented part of the course, which, if you've only taken CISC101 and CISC121, will be new to you. Right, but for now, we're still doing stuff that you may or may not have seen in 101/121. Okay? So strings. So we've seen some strings in Java, right? And you know what a string is in Python, right? Now in Python, a string, there's no such thing, the parts of the string, like the individual characters of the string, they don't have a special type, right? In Python. But in Java, a string literal is a sequence of characters, right? So remember what a sequence means in computing science, right? A sequence means it's ordered. So 0, 1, 2, 3, 4, 5, right? It's a sequence of characters between double quotes, and the characters that actually make up the string, well, they actually have a type, right? So the characters in a string have the primitive type char, C-H-A-R, right? So that string S, that's the string, well, it's the sequence of characters rub-a-dub-dub, right? You can ask the string for the first character of the string, right? There's a method called charAt, which will give you back a character in the string at position 0, right? And you can store that in a variable of type char, right? Little c char. Okay, so the characters in a string in Java, they actually have their own type. Now char, because it's primitive, there are also what are called literals, right? So there are characters that you can write down, right? And the way you indicate that you want to write a char literal is you use the single quotes, right? Use the single quotes. Right, and again, that's different than Python too, right? Because in Python, if you use single quotes, you get a string. In Java, you get a char. And there's a few more restrictions on this, right? If you use the single quotes to indicate a char, right, there has to be exactly one character inside the quotes, right? So I can write char C equals single quote A, and that's the character A, right? You can have a blank space, right? So that's single quote, and then a space, and then a single quote. But what you cannot do is write single quote, right? There's no such thing as an empty char in Java, right? Similarly, you can't put two characters in there either, right? So you can't put single quote AB, right? The compiler will flag it as an error, right? So there's no empty char. And in Java, the char type is actually one of the integer types, which is a little weird, right? Because if you go back here, right? I just told you that the characters in the string rub-a-dub-dub, those are all chars. And now I'm telling you they're actually numbers, right? Which is strange. So the way chars work is that they are an integer value, but when you go to print them out or do some sort of computation with them, then what happens is they get mapped to a character of some kind, right? And in Java, the mapping is defined by something called the Unicode Standard, version 6.0. 6.0.0. There are newer versions of the Unicode Standard for which char doesn't work anymore, which is kind of interesting. So you might ask the question why. Oh, sorry, let's take a look here. So because it's an integer type, right, there is some minimum value and there's some maximum value that char can take, right? And it turns out the minimum value is 0 and the maximum value is about 65,000, right? That's 2 to the power 16 minus 1, right, for those of you who know about binary. Okay, I'll get to the cast in front in just a second, right? So it's defined by the Unicode Standard, and it looks like there's a lot of different chars, right? Many more chars than you can actually type in on your keyboard with a single character, right? And the reason that is because there's lots of different languages in the world. So the Unicode Standard tries to define a standard whereby every written symbol in the world has some representation, right? And then there's a bunch of other funny symbols as well, right? So you can get like all sorts of shapes and other things. So it's worth taking a quick look at this standard, not the standard, but how these values map, right? So if you have the char value 0, right, that maps to something called the null character or no character, right? And if you look at this little table right here, most of these you can't actually print on your keyboard, right? So these are the non-printing characters, right? But they do mean something, right? And you can use them in a Java program, right? And if I keep on scrolling a little bit, right, on the Wikipedia page, the next section describes what are called the Latin characters. So these would be the English, this would be letters, symbols, numbers in the English alphabet, right? And you can see that at 32, right, is where you start to get the things that you can actually print, right? So you get a space, right? Exclamation marks 33. The letters, the digits start at 48, right? And then the letters, they don't start until like 65, right? And notice that the uppercase letters come before the lowercase letters, right? So little a is at character 97. All right, and I'm going to do the usual thing of every once in a while checking on the stream. Still there? Uh-oh. Oh, hang on. Okay, we're still live. Okay, now, when you go to print a char, right, Java doesn't print out the number, right? So what it does is it does the mapping, right? So if you, right, character min value is some char, right? So if I just printed it out on its own, remember I just showed you it's the null character, so you don't see anything on the screen. Character max val is 65,535, and I don't actually know what letter or what symbol that maps to. But if you print that out, nothing shows up either, right? If you print out like the number, the char, sorry, like 65 here, right? You get an A, right? So if you want to print out the numeric value of the character, right, the actual numeric value, you have to convert the char to an int. Right? And so that round bracket int and before the character min value, that's what's called a cast in Java, right? It's converting whatever value that is, right, to an int value, and then println prints out the integer value corresponding to that character, right? Okay. Now you can do arithmetic with chars too, because chars are just they're just numbers, right? So I can write something like c plus equals 25. Which you can interpret to mean c equals c plus 25, right? So if I start out at A and I go 25 places down the alphabet, right, then you get Z. So that all seems to make sense, right? So you can do arithmetic with char, but the results are very unintuitive, right? So the first time I did this, I didn't start programming in Java until I had programmed in many other languages before. Right? So when I first started playing around with cars and doing arithmetic with them, I was wondering why I was getting so many errors. Right? And that's because the results you get are very odd, especially if you come from another language. And the results are very odd, especially when int values are involved. Right? So for example, let's start out with the charAt. Right? If I write C++, everything's fine. Right? The Java language is perfectly happy with that. You add 1 to A, right? And that gives you the letter B. Right? If you write C plus equals 1, right, you might look at that and say, that looks a little funny, maybe, because 1's an int. Right? And you know now that when you do mixed arithmetic, right, Java tends to convert things to the wider type. Right? And int is wider than char. And so you might say, well, look, now I'm adding something, an int to a char, and then putting it back into a char. Right? So C plus equals 1 you can think of as being C equals C plus 1. Right? And so you say that should throw a compiler error, because you can't convert an int to a char automatically, but it works. So the way that the language is designed is that when you write C plus equals 1, that's fine. Right? That's the same thing as adding 1 to C. Right? So now we have the character uppercase C. Right? You can write C minus equals 1, right? And you now go back to the uppercase letter B. What you can't do is you can't write C equals C plus 1. Right? Even though, right, it's similar to that statement right there. Right? You can't write that because now Java says, well, the type of C is char. Right? So that's a char, and I'm adding an int to it. Right? So Java says, well, I'm going to use int arithmetic because I have to convert to the wider type. Right? That's an int, so I convert the char to an int. Right? It does the arithmetic, and then it tries to put the answer back into an int, and now you get an error. Right? So the operator plus equals, minus equals, star equals, and slash equals, they're all defined so that they work if you pass it, if you give it an integer value on the right-hand side. Right? But plus does not. Right? So that's very strange. Right? Even weirder is if I make another char. Right? So I make a char D, and it's equal to the letter B. If I try to add those together, Java says, no, you can't do that. Right? And you say, well, why not? Right? C is a char. Right? D is a char. Why can't I add C and D? Right? And that's because it turns out addition for chars is not defined. Right? So what Java does here is it actually converts the C and the D to int and uses int arithmetic. Right? So the only proper arithmetic you can do in Java is with int, long, double, and float. Right? Otherwise, not all the operators are defined. Right? So if you're working with byte, char, or short, and you're trying to add or subtract stuff, it doesn't work. You have to cast everywhere, which is really annoying. Right? But that's strange. So you have to remember that straight addition or straight subtraction or straight multiplication not defined for the char type. Okay? That's why very unintuitive. Right? So you have to be careful when you're working, when you're doing arithmetic. And now you might ask, well, why on earth do you want to do arithmetic with letters? Right? So it's super useful when you want to generate a sequence of characters. Right? So suppose I want to generate the sequence A, B, C, D, E, F, G. Right? And I don't want to type it in. Right? Then you would use a loop. Right? So for char C equals A, right? Remember, that's actually just a number. Right? I know Z comes after A, so I can write as long as C is less than or equal to Z. Right? Increment the value of C by 1. Right? That all works. So here I'm going to generate all pairs of 2-letter uppercase words, strings. Right? So if I want to generate all pairs of 2-letter uppercase strings, I need a nested loop. Right? So I have an inner loop that goes from A to Z as well. Right? And then I make the string inside the loop. Right? So when I build the string, I write empty string plus C plus D. Right? So I start with the empty string. Right? I concatenate the string version of C. Right? And then I concatenate the string representation of D onto the end. Right? So that's actually concatenation, not char arithmetic. The arithmetic's happening here. C++ and D++. Right? And if you run that if you stick that into a main method and run it, right, you end up with a sequence AA, then AB, then AC, all the way through to ZZ. Right? So that's why you want to do arithmetic. Right? Sometimes there's a problem that you want to solve that involves a sequence of letters, right? And it's not unusual when you're computing strings, right? So when you're computing the value of a string, it's not unusual to be doing something like this. Okay, so that's char, and now I want to talk about strings. But before I talk about strings, I have to tell you about types, classes, and objects. Right, so you may or may not have been told this in your previous courses, right? So fundamental to many programming languages is the notion of a type, right? So a type is just a set of values and the operations that you can do with those values, right? So you know that there's a type called int, right? What are the values of int? Well, they go from integer min value to integer max value, right? What can I do with those ints? Well, I can add them, subtract them, divide them, and so on, right? So int is a type. I guess int in Java is a primitive type, right? Now, I told you in a previous lecture that there are also these things called reference types in Java, right? And reference types are defined by what are called classes in Java, right? So whenever you write public class blah, you've just defined your own type, right? And an object is what's called, we say, is an instance of a class, right? So let's dissect that for a second. So let's go back up to here, right? I told you, you know int is a type, right? The number 1 is an int, right? So the number 1 is an instance of an int, right? When you talk about objects, so when you're talking about classes, right? You talk about objects, and objects are just instances of the class, right? So back on the first slide, right, that string s equals rub-a-dub-dub, right? We say that there's a string object, right, that represents the sequence rub-a-dub-dub, right? And we say that that string instance is an object, right? So it's an object of type string, right? So somewhere in memory, there's an object that represents that string, right? So whenever you see object or instance, it means the same thing, right? Okay, so there's something called the string class in Java, right? So these things in double quotes, they're actually objects, right? Just like in Python, actually. So Python, whenever you see something in single quotes, double quotes, or triple quotes, there's a string object somewhere in memory corresponding to that object, right? So a string object is the thing that represents that sequence of text, right? So again, right, somewhere in memory, there's an object that represents rub-a-dub-dub, right? And strings are fundamental to the Java programming language, right? They're very, very widely used in Java programs. And because they're so widely used, the Java language actually goes out of the way to let the programmer use string objects. Well, it almost provides the illusion that string objects are actually primitive types, right? So there's a lot of things that you can do with strings that you can't do with other reference types. Right? So for example, you can use double quotes and write down a string literal, right? You can't do that for any other reference type, right? There's no literal for any other reference type in Java, right? The plus operator is defined for strings as well, right? So that does string concatenation, right? But there's no arithmetic or comparison operator defined for any other reference type. Right? So the designers of the language went out of their way to make it look like string was just a regular primitive type. Right? Okay, now the string class is huge, right? So it has lots and lots and lots of methods. So it has lots of things. A string has the ability to do lots and lots and lots of different things. Right? When you start to work with objects, you need to know where do I find information about the classes that define the objects. Right? So string's part of the Java standard library. If you hit that link, or a link similar to that, right, that will take you to the documentation for a string. Right? This is the Java version 8. It doesn't matter. I mean, the string class hasn't changed in a long time. So it doesn't matter which version of the documentation you find for string. It's going to be sufficient. Right? If you do look at that documentation, it's a huge web page, right? With dozens, maybe, yeah, dozens of methods for sure. Right? Later, so when you're reading the notebooks, there's actually a notebook that tells you how to read one of these documentation, one of these documents. Right? And there's a video and everything, right? So you can go and learn how to read one of these documents. I'm not going to show it to you now. Instead, what I'm going to do is I'm just going to show you some examples of how to use strings. Okay, like Python, string objects are immutable, right? So what does that mean? So when I write single quote or double quotes rub-a-dub-dub, there's a string object in memory that represents rub-a-dub-dub. And it always represents rub-a-dub-dub, right? That object always represents the same sequence of characters, right? There's no way for the programmer to change that sequence, right? You can make a new string, right? So you can make a capitalized version of rub-a-dub-dub, right? But that's a new string object, right? So now there's a second object in memory, right? It represents a different sequence of characters. Right? So there's no way to actually change the sequence of characters in a string once you've made the string. Now, for new programmers, this is weird because when you start to use the string class, there's a bunch of methods that look like they actually change the characters of the string, right? They don't. What they do is they return a new string object. Right, so any method that looks like it modifies the string, in fact, it can't because strings are immutable. Okay, so for example, there is this method called touppercase that, not surprisingly, takes a string and gives you back, and then seems to convert the string to uppercase. Right? That's what it looks like it does, but that's not what it does. Right? Similarly, there's a method called toLowercase that looks like it ought to take a string and convert it to all lowercase, but that's not what it does. Right? Instead, right, so if I start out with the string hello and I use the object s or the reference s, so a lot of the time when you're reading textbooks or if you're reading documentation online or something like that, right, you'll see that they'll refer to s as an object. Right? Strictly speaking, that's not true. Right? S is a reference to an object, but it gets really old fast writing S is a reference to an object every time. Right? So most people just say S is an object. It's not precisely true, but it's close enough. Right? So I can call the method touppercase using a string reference. Right? That's a little different. Right? So every method we've called so far, almost every method we've called so far, right, you've used the class name to call the method. Right? Now I'm using an object reference. Right? So I'll explain more about that in a second. Right? So s.touppercase means take the object s, call the touppercase method on it. Right? And what that does is it returns a new string that's capital H, capital E, capital L, capital L, capital O. Right? The original string s is unchanged. Right? So when you print out s, right, you get the lowercase hello, and then when you print out up, you get uppercase hello. Right? Two different string objects now. Right? And the common error that programmers new to Java do, the programmers new to Java will try to do is they'll write s to uppercase and think that s is now all in uppercase. Right? But it's not. S is still in lowercase. Right? So writing that actually does, effectively it does nothing. Right? Java returns a new string that's the uppercase version of s, and then throws it away, right? Because you didn't assign it to anything. Right? Remember that thing returns a value, like up here, and you didn't assign it to a variable anywhere, so it just throws away the result. Right? Nothing happens to s, so effectively nothing has happened. Yeah. Yep. Yeah. You'll print out uppercase hello. Yeah. But you can't get the object anymore. Right? You don't have a reference to the object, so you can't use it again. Okay. Now, oh, right, back here. Okay, now. I've been telling you that all of our methods so far are static, but it turns out that's actually the most unusual case, right, in Java. In Java, most methods are not static, right? So to call a static method, you use the class name, right? To call a non-static method, you need an object reference. Right? So in Java, you always need something to call a method. Right? You either need a class or you need an object. Right? Here, I'm using an object, right? Because I have to, because touppercase is a non-static method. Right? Because it's non-static, that means I need an object. Right? If you have a static method, that means you need a class. Right? So that's the distinction between static and non-static for methods. Right? Static method belongs to a class, so you call it with the name of the class. A non-static method is associated with an object, so you always call it with an object reference. Right? If you try to call touppercase with string.touppercase, it doesn't work. right? The compiler will complain, and it says you're trying to call a non-static method in a static way, right? OK, good. Now, string does have static methods as well, right? So if you hit that link that I showed you a couple of slides ago, right, and you scroll through, you will see that at the very bottom of the class, there's a bunch of static methods, right? Remember, you use the class name to call a static method, right? And so one of the static methods is this thing called value of. And there's actually several different versions of this method, right? So there's a different version of this method for every primitive type. And what that lets you do is it lets you take a primitive value, like 1.0, and get its string representation, right? Which in this case is just the string 1.0, right? So if you ever want to convert a primitive type to a string, or if you ever want to take a primitive type and get its string representation, you can always use big S string dot value of and the thing that you want to get the string representation of, right? But it's a lot easier to write that, right? So, well, it's a lot shorter to write that, right? So what does this do? This takes the empty string, right, and then concatenates that with the string representation of 1. Right? So that one, the compiler will end up calling, what does it actually do? It's actually a little bit complicated what that actually does, right? But effectively, they end up doing the same thing, right? But there are static methods in string, right? If you want to call a static method, use the class name instead, right? If you try to use an object here, it won't work, right? So if you had some other string t and you said t value of, it won't work, right? It's static, so you must use the class name. OK, like in Python, a string is a numbered sequence, right? So the string CISC124, right? You can think of that as just being, you can almost think of it as being an array, right? And each letter gets its own number, right? In order, starting from 0, right? So the first C in CISC124 has the index 0, right? The I has index 1, the S has index 2, and so on, and so on, and so on. Right? The number of characters in the string is called the length of the string, right? How do you get the length? Well, there's a method called length, right? So if I have the string course name, right, that's the string CISC124, then the length of that is just course name dot length, right? So again, non-static method, right? And if you think about what I just said about non-static and static, right? Remember I told you a non-static method is associated with an object, right? So if I want the length of any particular string instance, right, I need to ask the right object for its length, right? If I could write big S string dot length, that doesn't make any sense, right? Because if length was static, it would belong to the class, right? And the class has no idea how long that is, right? So you need to ask, hey, you need to find an object and ask the object, hey, how long are you? Right? Well, now it says it's 7. Right? Now, unlike characters, there is such thing as the empty string. Right? So the empty string is just double quotes with nothing in between them. Right? And because it's empty, its length is 0. Right? If you ever want to check if a string is empty, you can do empty.length equals 0. But what you should do is use the method isEmpty. Right? So it's not on the slide. But if you wrote empty.isEmpty, that will return true or false. Right? It returns true if it's empty, and returns false otherwise. Right? So here it will return true. OK. Right? Oh, sorry. In Python, you would just write len and then the name of the string. Right? So there's no length function in Java, so we need a method. OK. Now it's a numbered sequence, right? In Python, you can use square brackets to get a substring from a string, right? In Java, you have to use charAt, right? So there's a method called charAt that returns the character at a specified index, right? It's a numbered sequence starting from 0, right? So the valid indexes are from 0 up to the length of the string minus 1. Right? Because we count from 0, right? We start counting from 0. Right? You're not allowed negative indexes in Java, right? So unfortunately, if you want the last character of a string, you have to do the awkward length minus 1 thing, right? To get its index. Okay, so here's our string again, CISC124, right? I'm going to write a loop, right? All it does is it loops over the individual indexes of the string, right? So that's got a length of 7. So I have the valid indexes 0, 1, 2, 3, 4, 5, 6, right? How do you write a loop in Java that counts? Well, int I equals 0. I is less than the length of the string. Each time through the loop, add 1 to I, right? Inside the loop, I'm just going to call charAt I, right? From which object am I asking the character from? Well, I want the course name object, right, to get the character from, right? That returns a char, so I can store it in a char. And then I can print it out or do whatever I want with C, right? So here I just print out C. And that will print out capital C, then on the next line capital I, then on the next line capital S, and so on until you get the 4. Right? So it just prints out each letter of CISC124, 1 character per line. And now here's a method that counts the number of times a specified character appears in a string. Right? So I've got my class called strings with an S. Right? I've got a public static method, right, that returns an int. Its name is freq, so that's short for frequency. Right? It has 2 inputs. Right? It has a string S, and it has a character called target. Right? And what this method's going to do is it's going to count how many times the character target appears in the string S. Right? So this is just a simple counting problem. Right? You start with a count of 0. Right? You now look at every character in the string. Right? So here's my loop that loops over the characters of the string. Right? I get the character at that index. Right? So if the character belonging to S at index I is the same as that target character, so equals equals, right? Then I add 1 to the count, right? Because I found a character that I'm looking for, or I found a character that's equal to the target, and then at the end of the loop, you just return the count. Right? So there's your loop. There's charAt, right? And here's another example of writing a static method. And here's how you would use that method. Right? So in another class somewhere else, right? So public class test strings, right? I've got a main method. There's my string CISC124, right? How many times does the letter C appear in the course name? Right? How do I call the method? It's static, right? So I need the class name, strings.freq, right? You should get 2 if you run that, right? Because the letter C, the capital C appears twice in CISC124. Strings are case sensitive, or characters are case sensitive, right? So little c is different than big C. So if I call strings.freq course name comma C, right? That gives you back 0 because little c does not appear inside CISC124, right? If I ask for how many times the character 4 appears, right? Not the number 4, right? The character 4 appears, you get 1, right? Because it shows up at the end of the string. Right? Okay. String has a method called contains that will tell you if a specified character is in a string. Right? True, if a string, contains a specified substring. Sorry, not a character. It'll tell you if it contains a specified substring. Right? It would be nice if there was a method that tells you if it contains a specified character, but it doesn't. Right? Okay, so here's a course name again, CISC124. Right? Contains. Course name dot contains capital CISC is saying, does the string course name contain the string big CISC somewhere in it? Right? The answer is yes, right? Because it's right at the front. Does it contain little CISC? The answer is no, right? So that's false. Right? Does it contain the string 4? Right? The answer is yes. If you asked it, does it contain the string? Does it contain big C, big S? The answer is no. Right? There is a C, there is an S, but the sequence is CIS, right? So there is no sequence CS. There's no subsequence CS inside that string. Right? Now, unfortunately, there's not a version of this that tells you, does the string contain a specific character? Right? So if you wrote, does course name contains the character C, you get an error. Right? So Java says, the compiler will say you can't do that because there's no method that takes in a char. Right? So if you want to do that, you have to take that char and somehow get its string representation. right? The easiest way to do that is to just concatenate it with the empty string, right? And so that asks you, is the string C inside CISC124? And the answer is yes. Right? Okay, so contains will tell you, does it contain a substring, right? Index of will tell you where in the string is a specified character, right? It returns -1 if the character is not in the string, right? So again, the same string, CISC124, right? What's the index of the C? Right now, CISC124 has got 2 C's in it, right? And so what index of does is it returns the index of the first character that appears that matches the target character, right? So where's the location of the first capital C? Well, it's the first letter of the name, first letter of the string, so that gives you back a 0, right? Where is the capital S? 0, 1, 2, right? Where is the 4? It's at the end, that's 6, right? And where is the little case z? Well, it's nowhere in that string, so you get back -1, right? Now, often it's the case where you don't want the first one, but you want the last one, right? So last index of gives you back the index of the last location of the specified character, right? Gives you back -1 if the character is not in the string. So these are all going to be the same, right? Because there's only one S, one 4, and there's no Z. However, there are 2 C's, right? So the answer here, compared to the previous slide, is different, right? The index of the last C is 0, 1, 2, 3, right? So you get back to 3 in this case. There's no easy way to get back the index of like the second instance of a character, or the third instance, or the fourth instance. Right? You have to write your own little, you have to write some small fragment of code to do that. Right? Okay, now, there's something you have to be really careful about in Java, especially when you're coming from Python. Right? And especially having seen what's on the slides so far. Right? When you want to check if 2 strings represent the same sequence of characters, right? In other words, are the 2 strings equal? You have to use the equals method, right? Whatever you do. So this is the most important thing you're going to learn in this lecture. Do not use equals equals to compare strings for equality. Okay? Whatever you do, do not use equals equals to compare 2 strings for equality. The problem with strings is it usually works. Until it doesn't. And then you spend hours debugging your program trying to figure out what the heck just happened. Right? Whenever you have 2 reference types that you want to check for equality, you always use the equals method. Okay? Whenever you have 2 primitive types that you want to check for equality, that's when you use equals equals. Right? And this is different than Python. Right? In Python, you always use equals equals. Right? To compare anything, right? For equality. Right? In Java, when you're working with reference types, use the method equals. Okay? So I have 2 strings, right? CISC124, math124. They have different names, right? There's variables that point to them that have different names, right? I want to check, are they equal, right? So the way you write that is CISC.equals math, right? You could also write math.equals CISC, right? And that's just comparing, do the 2 strings represent the same sequence of characters, right? So that's false. Case matters, right? So if you write CISC.equals lowercase CISC124, that's false. Whenever you write CISC.equals CISC, that's always true, right? Math.equals math, that's always true, right? Okay, so you know that the plus operator, that's the concatenation operator, right? It joins 2 strings, right? So here I have the name James Bond 007, right? Here I have a second variable, right? Name 2. And that's equal to the string James with a space, right? Plus the string Bond with a space, plus 007, right? The plus operator just joins the strings together, right? So you take James space, join it with Bond space, and then join that with 007, right? Should be obvious that you get the same sequence of characters as name 1, right? So name 1 equals name 2, well, that's true, right? So you can join strings together. You can concatenate primitive values onto a string, right? So same code as the previous slide. Now I'm going to do it differently. I'm going to write James Bond space, right? Plus 0, plus 0, plus 7, right? Now 0, 0, and 7, these are all ints, right? So you might ask yourself, does this actually work? The answer is yes, it actually works, right? Name1 equals name3 is true, right? The reason it works is because you have a string in the front, right? And you have plus, plus, and plus, right? So you have the same arithmetic operator applied multiple times, right? Java goes left to right. It sees a string and then an int. So it knows immediately that it has to do string concatenation instead of addition, right? That returns a string right after you do that, and then it sees a string with an int, right? Java says, OK, concatenate. And then you get a string, right, plus an int. And so Java says, OK, I'm going to do string concatenation again, right? And that works. That works fine. Now, what you have to be careful about is don't do something like this, right? Because you have to, this is a common thing to do where you take a string and try to stick a primitive onto it, right? It's also a common thing to take a primitive and stick it in front of a string, right? But what you can't do is you can't take two primitives and then stick it in front of a string, right? Because of the precedence rules in Java, right? Something plus something plus something. So Java goes left to right. It sees h plus a, right? It sees the character h plus the character a. So now it does int arithmetic, right? Converts the h to its integer value, converts the a to its integer value, adds them together. Turns out you get 201, right? That becomes an int concatenated with a string. So you get 201 ha, right? Which isn't what you probably wanted, right? So whenever you're doing something like this, just stick the empty string in front, right? So write string laugh equals empty string plus h plus a plus ha, and everything's fine, right? You always want to start the concatenation out with a string, and that will get rid of all your problems. Okay. The notebooks have other examples of when you're going to run into trouble. OK, slicing a string. In Python, you can slice any sequence, right? Which is, I mean, it's really one of the nicest things about the Python language. So if I take the slice 1 colon, right, that's the substring starting from the second character of S, right? So starting from the B, the rest of the string. S3 colon 4, that's the slice starting at character 3, right? Going up to but not including the 4. So that's just the D, right? 5 colon 7, start at index 5, go up to but not including the 7, right? So that's 0, 1, 2, 3, 4, 5. So that's F. G is index 6, so I take that one as well, and then you get the string FG. Right? You can't write the exact same thing in Java, but there is a slicing method in Java. And it's called substring. Right? So you use the exact same numbers. It's just you write it in a different way. Right? So if I want everything not including the first character, it's substring 1. Right? If you wanted everything not including the first 2 characters, it would be substring 2. Right? Substring 0 just gives you back the original string. Right? Substring 3, 4, start at index 3, go up to but not including the 4. Right? So that gives you the D. 5, 7, start at index 5, go up to but not including the 7. Right? And that's FG. OK, I think this is, where are we? 27, we're getting towards the end. Good. The other nice thing about Python, so Python really goes out of its way to make it easy to write code. Unfortunately, it also makes it easy to make mistakes, and it's easy to make mistakes that are hard to find. One of the things it does is it overloads the mathematical operators, the comparison operators, right? So it's possible in Python to write a class that can use less than, greater than, and equal to, right? And that's true for strings, right? So whoever wrote the string class in Python defined less than and greater than and equal to mean something, right? So less than means does the string S come before T in the dictionary, right? So in other words, it compares what's called their lexicographical order, right? So does A become before Z? Yes, the answer is true, right? Greater than is does S come after T? So obviously it's false. Right? Equals equals is the same as dot equals in Java, right? So is A equal to A? The answer is yes, right? Java does not let you do that, right? So Java did not overload the comparison operators. for any reference type, including string. Right? So if you want to do something like that, right, and it's, you can imagine this is a very common operation, right? Does this word come before this word in the dictionary, right? You use the method called compare to. Now compare to is a little bit harder to use than less than, greater than, and equal to. Right? So s dot compare to t, right? So if s comes before t in the dictionary, you get back a negative integer, right? You have to look at the documentation for the class to find out what the meaning of the integer is, right? But it gives you back a negative integer, right? So if s is less than t, give you back a negative value. If s and t represent the same string, in other words, if they're equal, you get back 0, right? And if s comes after t in the dictionary, you get a value that's greater than 0, right? So now you're comparing relative to 0, right? You get a negative value, then s is less than t. You get 0, s is equal to t. And if you get, if you get a positive value, then s comes after t for strings. You have to be careful with the middle one. Okay? For strings, it's the case that s equals t is true, right? If you get back 0, right? That's not the case for every class in Java. And we'll get to that in a few weeks, I think, when we talk about how to write the compare to method. Right? But for strings, if they're equal, then you get back 0 when you compare them. Right? So how do you use this? Well, I've got the string aardvark and zebra, right? So that's s, right? That's t. S compared to t. What do I get back? Well, s comes before t in the dictionary, right? Well, aardvark comes before zebra, right? So I get back some number that's less than 0, right? S compared to s. Well, aardvark is the same string as aardvark, so I get back 0. T compared to s. So zebra comes after aardvark in the dictionary, so I get back a value that's greater than 0. Right? So now you have to use s compared to t less than 0, s compared to t equals 0, or s compared, or something t compared to s greater than 0 to, for your conditions. Right? So it's a little more verbose than the Python greater than, less than, greater than, and equal to. Okay. Now there's a bunch of other methods. There's a lot of methods in the string class. I'm not going to cover them all. Right? Sometimes you want to replace characters in a string. Right? There's a method called replace. Right? So there's my string s. Right? S replace p with t is what that is, how you read that. Right? So replace every p with a t. Right? And assign it to the string t. Right? You remember, strings are immutable, right? So if I just write s replace pt, nothing happens, right? I have to take the result and store it in a variable, right? Because I'm getting back a new string from this method, right? So when you replace every p with a t, you get starring with a turtle tortoise, right? If I reassign s to point to a new string, right? So here I've got s equals that string now, right? So it's not changing the original string, right? I'm making a new string object and assigning that string object to s, right? I'm doing the same thing with t, right? I'm not replacing whatever that answer is, right? I'm not replacing starring with a turtle tortoise. What I'm doing is I'm making a new string that's the replacement of hi ho with oh no, right? And assigning that to t, right? So I can use this. So I can use a character, right? Or I can use strings. They don't have to be the same length, although they are in this example, right? So here it replaces every hi ho with oh no, right? And you get oh no, it's off to work we go. And that's it. Good. That's perfect. So you should know that assignment 1 is out, right? If you've been paying attention to the lectures, right, watching the lecture slides, or watching the recorded videos or anything, the assignment is literally line for line translation, right? The lecture slides tell you how to do everything there. Okay? It's due not Monday, but the next Monday.